Marcus was healthy, 43 years old, no medications, no chronic conditions. He had just returned from what his family described as the trip of a lifetime, a cruise through the South Atlantic, Antarctica, remote islands most people never see. 5 days after he started feeling unwell, he was dead. His wife, who had been by his side the entire voyage, collapsed at an airport 2 days later. She didn't make it either. And here is what makes this story different from every other medical mystery we have covered. We know exactly what killed them. We have known about this virus for over 30 years. The biology is documented. The history is documented. The way it destroys the body is documented in extraordinary detail. And yet, most people had never heard of it until April 2026. In May 2026, the World Health Organization confirmed a cluster of hantavirus cases aboard a Dutch-flagged cruise ship called the MV Hondius. As of May 12th, 9 cases had been confirmed. 3 passengers were dead. Passengers from 23 countries had been on board. People had already disembarked and flown home to 6 countries across Europe, Canada, and the United States. The CDC classified it as a Level 3 emergency response. And the question that every news outlet on the planet was asking was the same: is this another pandemic? Today, we are going to answer that question properly, not with panic, not with dismissal, but with the biology. Because once you understand what hantavirus actually does inside the human body, you will understand exactly why the world responded the way it did, and exactly how worried you should actually be. Let us start with what happened inside the lungs. Your lungs have one job. They pull oxygen from the air you breathe and transfer it across an incredibly thin membrane into your bloodstream. That membrane, the alveolar wall, is only 2 cells thick, 2 cells between the air outside and the blood inside. Now imagine that wall begins to leak, not from a cut, not from physical damage, but because something invisible has instructed your own immune system to attack that wall from the inside. Fluid from your bloodstream begins seeping through, slowly at first, then faster, filling the air sacs that were designed to hold oxygen with liquid instead. You cannot breathe because your lungs are drowning. From the outside, you look like you might have pneumonia, or a heart problem, or a blood clot in the lung. The X-ray shows fluid everywhere. Doctors run every standard test. All of them come back negative. Because this is not a standard infection. This is hantavirus pulmonary syndrome. And it can go from fever to respiratory failure in less than 48 hours. To understand how this virus works, we have to go back to where it came from. Hantavirus was not discovered in a laboratory. It was discovered on a battlefield. In 1951, United Nations troops stationed along the Hantan River in Korea began reporting a mysterious hemorrhagic fever. Soldiers were developing fevers. Their kidneys were failing. Some of them were dying. No one knew what was causing it. It took 27 years. In 1978, a South Korean scientist named Ho Wang-ri finally identified the virus responsible. He named it Hantavirus, after the river where the soldiers had fallen ill. And when scientists began looking more closely, they discovered something remarkable. Ancient Chinese medical texts had described almost identical illnesses thousands of years earlier. This virus had been circulating in human populations for a very long time. We had simply never identified it. Now, here is where the biology becomes important. Hantavirus does not primarily live in humans. It lives in rodents, mice, voles, deer mice, specific species in specific geographic regions. Crucially, the rodents do not get sick. The virus circulates in them silently, indefinitely. The problem begins when those rodents excrete the virus. in their urine, their feces, their saliva. When those secretions dry out and become airborne particles and a human inhales them, the virus enters a body it was never designed to inhabit. And what happens next is not the virus destroying you directly. It is your own immune system trying to fight the virus, and in doing so, destroying the very walls of your blood vessels in the process. This is what fills the lungs with fluid, not the virus itself, the immune response. This is why hantavirus is so difficult to treat. You cannot simply kill the virus and expect the damage to stop, because the damage is being done by your own biology. Now, the important distinction. Not all hantaviruses cause the same disease. There are over 50 documented species in the hantavirus family. Most of them cause kidney failure. A smaller group, the ones found in the Americas, cause the pulmonary syndrome, the lung flooding. And one species, only one, has ever been confirmed to spread from human to human. It is called the Andes virus, and it is the one that was found aboard the MV Hondius in 2026. May 14th, 1993. A 19-year-old man was driving through the Four Corners region of the American Southwest to attend his fiancée's funeral. She had been 21 years old, a marathon runner, previously completely healthy. She had died suddenly after developing trouble breathing. He never made it to the funeral. Halfway through the drive, he pulled over at a gas station because he could not breathe. An ambulance arrived. Before it could get him to the hospital, he collapsed. By the time doctors examined him, his lungs had filled with fluid. Within minutes of arrival, he was gone. Two previously healthy young marathon runners, separated by weeks, both dying the same way, and no one had any explanation. The New Mexico office of the medical investigator was contacted, and investigators quickly learned this was not isolated. Similar deaths were being reported across the Four Corners region, all in previously healthy patients, all with lungs suddenly full of fluid. The initial mortality rate, 80%. The CDC was brought in. They tested autopsy samples, and deep in the genetic material of the deceased, they found something that had never been described before, a new species of hantavirus, one that had apparently existed in North America all along, simply never identified. They named it sin nombre, meaning no name. Public health investigators went to the homes of the deceased. They found rodents, deer mice. When they tested them, they carried the same genetic material. And then the question became, why 1993? Why had cases suddenly appeared that year? The answer came from a volcano. In 1991, Mount Pinatubo in the Philippines erupted. It sent 20 megatons of sulfur dioxide into the atmosphere. It triggered a volcanic winter. Global temperatures dropped 0.5 degrees Celsius for 2 years. This created abnormal precipitation patterns across North America. The Four Corners region experienced record rainfall. Vegetation exploded, and the deer mouse population, with abundant food, multiplied by 10 times. More rodents, more infected rodents, more airborne particles, more humans exposed. The virus had always been there. It just needed conditions to find us. 2 years later, in 1995, researchers investigating similar deaths in Patagonia, Argentina, found yet another new species, genetically distinct from sin nombre, unique to South American rodents. They named it the Andes virus, and the following year, It did something no hantavirus had ever been documented to do before. It spread from one human to another. This is the part of the Andes virus story that separates it from every other member of the Hantavirus family. In 1996, in the same small Argentinian town where the Andes virus had just been identified, a cluster of infections was documented that changed how scientists understood this pathogen. Person-to-person transmission, confirmed. And then, in 2018, in the town of Epuyén and Patagonia, it happened again, on a scale that gave researchers the clearest picture they had ever had of exactly how this virus moves between humans. One person became infected. They attended a birthday party while still in the early stages of illness. People who sat within 1 to 2 meters of that person at the party subsequently became ill. One of the new cases, a person with an active social life, went on to infect 6 more people before they even developed symptoms themselves. 16 days after symptom onset, that person died. Their spouse developed a fever during the funeral. 10 people who attended the wake and came into close contact with the spouse subsequently became ill. In total, the 2018 Epuyén outbreak produced 34 infections and 11 deaths. But here's the critical piece of information that the 2018 Epuyén outbreak also confirmed. Not a single healthcare worker who treated the infected patients became infected. Think about what that means. Medical teams were exposed to bodily fluids. They handled the patients at the most infectious stages. They worked in intensive care environments, and with appropriate protective equipment, none of them became sick. This tells us something important about the transmission mechanism. Andes virus does not spread like influenza. It does not spread like COVID-19. It appears to require prolonged close contact, shared enclosed spaces, extended exposure. Not a greeting across a room, not a shared elevator, sustained proximity. This is the biological context that the 2026 MV Hondius outbreak must be understood within. The ship departed Ushuaia, Argentina on April 1, 2026. The current leading hypothesis from investigators is that at least one passenger was exposed to Andes virus while spending time in Argentina or Chile before boarding, where the virus is endemic in local rodent populations, and may subsequently have transmitted it to other passengers during the voyage. 147 passengers and crew, confined spaces, shared dining areas, extended time together at sea. The conditions the Andes virus needs. Let us talk about what happens inside the body hour by hour when Andes virus enters the system. Because this is where the science becomes genuinely frightening, not because of panic, but because of speed. The incubation period for hantavirus ranges from roughly 2 weeks to 8 weeks, according to the WHO Director General speaking to CNN during the outbreak. 6 to 8 weeks is the outer range. This is why epidemiologists tracking the MV Hondius outbreak expected additional cases to emerge even after passengers had disembarked and returned home. During incubation, you feel nothing. Then comes the prodrome, a period that looks almost identical to influenza. Fever, muscle aches, fatigue, headache, sometimes nausea. Nothing about this stage screams hantavirus. Nothing about this stage would make you leave a birthday party. This prodrome phase lasts 3 to 7 days, and then the cardiopulmonary phase begins. Within hours, sometimes within a single hour, the situation changes completely. Your oxygen saturation begins to drop. Below 90% requires emergency medical attention. Blood pressure falls. The kidneys may begin to fail, and the lungs, those 2-cell thin membranes, begin to flood. The mechanism is now well understood. The Andes virus infects the endothelial cells that line your blood vessels. These are the cells that maintain the structural integrity of the vessel wall. The immune system mounts an aggressive response, and in doing so, it compromises the very walls it is trying to defend. Fluid pours from the blood vessels into the tissue around them. In the lungs, this fluid fills the alveoli, the tiny air sacs designed to transfer oxygen into blood. They fill with liquid instead. The patient is breathing, but there is no oxygen exchange happening. The lungs are mechanically functional, but physiologically useless. A chest X-ray at this stage looks terrifying, both lungs filled with white. This is pulmonary edema, and it can progress from first symptom to intubation to death in under 48 hours. According to CDC data, not speculation, documented clinical data from cases across the Americas since 1993, the only treatment currently available is supportive care. There is no specific antiviral drug for hantavirus. Oxygen, mechanical ventilation, and in the most severe cases, ECMO, extracorporeal membrane oxygenation, a machine that removes the blood from the body, oxygenates it externally, and pumps it back in. According to the CDC, ECMO can improve survival rates to approximately 80% if started early enough. The key phrase is early enough.
Now we come to the question that was on every news broadcast in May 2026. Is this another pandemic? And the honest, scientific answer is almost certainly not. But the reasoning matters. The Andes virus is the only hantavirus confirmed to spread between humans. But even this transmission requires specific conditions that are not present in most daily human interactions. According to data from the 2018 Epuyen outbreak, only 2 to 5% of all Andes virus cases are estimated to involve human-to-human transmission. The vast majority of infections still come from rodent exposure. The natural reservoir for Andes virus, the specific rodent species that carry it, does not exist in Europe. It does not exist in North America, or Asia, or Australia. Without the rodent reservoir, sustained community spread in those regions is considered extremely unlikely by ECDC and WHO. The 2018 outbreak in Epuyen reached 34 cases and then stopped, not because of intervention, but because the virus lacks the transmission efficiency to sustain exponential spread. One infected person does not infect 5 others or 10 others. The conditions required are too specific, too sustained, too close. This is not a new virus. Andes virus has been known for 30 years. The 1996 and 2018 outbreaks established that the virus showed no significant mutations across 2 decades, and preliminary sequence analysis of the virus isolated from a passenger in Switzerland in May 2026, published on virological.org, suggested the same pattern. The virus has not changed to become more transmissible. It is not COVID-19. COVID-19 was a completely novel pathogen with no pre-existing population immunity, a respiratory virus whose transmission characteristics were unknown for critical months. Andes virus has been studied for 30 decades. Its behavior is documented. Its limitations are documented. The conditions required for transmission are understood. WHO assessed the risk to the global population as low. CDC classified it as level 3, which means significant enough to mobilize response infrastructure, but not an imminent threat to the general public. But there is a legitimate concern worth naming clearly. The incubation period of 6 to 8 weeks means that cases emerging from the MV Hondius may continue to appear for weeks after the ship docked in Tenerife on May 10, 2026. Passengers who were exposed but asymptomatic have returned to at least 6 countries. Some may develop symptoms. Contact tracing is underway. Isolation protocols are in place. The system is working as designed.
Here is what you actually need to know. Not the headline version, the biology version. The Andes virus does not spread through casual contact. It does not spread through shared air in a supermarket, or a subway car, or a school corridor. It requires the kind of prolonged close contact that happens in households, in caregiving situations, in the specific confined dynamics of an Antarctic cruise ship, where the same people eat together, breathe together, and share enclosed spaces for weeks. If you were not on that ship, your risk of contracting Andes virus from someone who was is exceptionally low, according to both WHO and CDC. The symptoms to be aware of are not subtle. They are not ambiguous. Fever, muscle aches, fatigue. These are the prodrome. Most people who get the prodrome feel ill, but not critically ill. The warning sign that requires immediate medical attention is respiratory distress, difficulty breathing, a feeling that you cannot get enough air, particularly if you have any history of travel to southern Argentina or Chile, or any contact with someone who was aboard the MV Hondas. At that point, go to the hospital. Tell them your travel history. Tell them your contact history. Because here is the critical difference that this 2026 outbreak has created. Before May 2026, most emergency physicians in Europe, North America, and Australia had likely never considered hantavirus in a differential diagnosis. The symptoms in early stages look like a dozen other things. Patients could have been misdiagnosed, treated for the wrong condition, losing the narrow time window in which ECMO and supportive care can make the difference between survival and death. Now, the alarm bells have been raised globally. Every emergency physician in the affected countries knows what to look for. They know which test to order. They know which isolation protocol to implement. The world knowing about this outbreak, even though the individual risk is very low, may actually save lives, because awareness is the only thing that closes the gap between a missed diagnosis and a correct one. So what do you actually do with this information? Wash your hands thoroughly before and after eating, after coming home, 20 seconds. It does not feel like much, but it is the most consistently evidence-supported intervention in infectious disease prevention that exists. If you feel sick with a fever, stay home. Protect the people around you. And if you have trouble breathing, especially if you have traveled to southern Argentina or Chile recently, or if you have had close contact with someone who has, go to the hospital. Tell them where you have been. Hantavirus kills quickly when it kills, but it can also be survived with the right care in the right time window. The body eventually clears the virus. The fluid recedes from the lungs. People have walked out of ICUs after 40 days on ventilators and made full recoveries. The biology is brutal, but it is not hopeless. What is never hopeless is being informed. That is why we decode these things. I'll see you in the next one.